Hi, and welcome to the videos for section 3.5 for Math 126. This is the first of 3 videos for this section. In this section, we're going to be looking at complex numbers. So up until this point, we've just been dealing with real numbers. Rational numbers, integers, natural numbers, things of that sort. Complex numbers is going to add a different class of numbers for us. And by definition, we have that a complex number is an expression of the form A plus BI, where A and B are real numbers now we have this new unit, and I is an imaginary unit. And specifically, I is equal to the square root of -1. So up until this point, if I had something like square root of -16, we said what? It's not a real number. Well, it's not a real number. It's an imaginary number, an imaginary unit. So if I is equal to square root of -1, I squared, if I square both sides of this, I squared is equal to -1, and this is a concept we'll be using a little later on in this section. The important thing here, A is what we call our real part. And then B, and the sign included with it, so this could be A minus BI as well, but just the value B is the imaginary part. So I don't include the I as the imaginary part. That's just an indicator to me that that's my imaginary number. So for example, if I have 3 plus 4i, the 3 is my real part, and the positive 4 is the imaginary. Of course, either of these values could be 0, so I could have something like 6i. In this case, my real part is what? My real part is 0. So let me line these guys up for you. So if I have 6i, my real part is 0. My imaginary part is 6. Positive 6. Or I could have -7. This is also a complex number. It's just the real part is -7, the imaginary part is 0. But it still qualifies as a complex number. So some algebra of complex numbers. So to add or subtract complex numbers, we combine the real parts and combine the imaginary parts. So if I had, for example, 3 plus 2x plus 5 minus 4x, I just combine the parts that don't have the variable, I combine the parts that do have a variable. Same idea here. If I have 2 complex numbers, I add the real parts together, that gives me one value. I add the imaginary parts, that gives me another part of it, another number. To multiply complex numbers, well, what do I have? A complex number is a binomial. So if I'm multiplying binomials, what do? I FOIL it. So first, outside, inside, last. And then I have what's also known as my powers of I. So if I have I to the first power, that's what? That's just I. I squared, well, I squared we know to be negative 1. Whoops, negative 1. How about I to the third? Well, using my exponent rules, I to the third is what? It's I squared times I to the first. So I squared is negative 1 times I to the first, which is I. So this is negative I. How about I to the fourth? Well, again, using my exponent rules, I can rewrite this as I squared times I squared, which is negative 1 times negative 1, which is positive 1. So in terms of when we're working with I, this is sort of our holy grail. If we can get something I to the fourth power, that's great because I to the fourth simplifies to plus 1. How about if we keep going? I to the fifth. Well, I to the fifth is what? It's just I to the fourth times I to the first, which gets me back to I. And this will just keep repeating. So if I have to simplify I to some power, I pull out as many values of 4 as I can. That just gives me 1, and whatever I'm left with, it's either going to be 1, 2, or 3. I know it's either I, negative 1, or minus I. So let's look at a few examples of this. So I want to express all these in a plus bi form. So the first one I have is 3 plus 5i plus 4 minus 2i. So this is our addition or subtraction. So I'm going to combine the real parts, combine the imaginary. So I have what? For the real parts, I have 3 plus 4. And then plus my imaginary, I have plus 5i minus 2i. So that's what? 7 plus 5 minus 2 is 3. So I get 7 plus 3i. So if this question said state the real and state the imaginary parts, my answer is what? The real part is 7. The imaginary part is plus 3, positive 3. And again, don't include that I value. How about same numbers but subtraction? So 3 plus 5i minus 4 minus 2i. So we have to be careful with these minus signs now. So if I combine, I get what? 3 minus 4. And then the imaginary parts, I have 5i minus a negative 2i, which is 5i plus 2i. So 3 minus 4 is negative 1. 5 plus 2 is 7. So I get negative 1 plus 7i. What if I multiply those same ones? Whoops, 3. So 3 plus 5i times 4 minus 2i. So if I FOIL it, I get 3 times 4 is 12. Outside, 3 times negative 2i, it's the same as if I do 3 times negative 2x. I get what? Negative 6x. It's just now I have this I value. So 3 times negative 2i is minus 6i. Inside, 5i times 4, so that's plus 20i. Now here's where we have to be careful. So 5i times negative 2i is what? Negative 10i squared. So I want this in a plus bi form. Well, this guy here, I squared is equal to what? This is equal to negative 1. So this whole piece, negative 10 times negative 1, is plus 10. So if I combine the real parts, I have 12 plus 10, that's 22. And the imaginary parts, 20i minus 6i is plus 14i. So you should get 22 plus 14i. And lastly, number 4. And this one's not really a plus bi form. Well, I guess it is. But it's simplifying using our powers of I. So if I have I to the 23rd, and I want to simplify this, what did I say? I said we want to try to rewrite this guy as powers of 4. So 23 divided by 4 is what? It's 5 with 3 left over. So I can say this is like I to the 4th, because that's the one I want to take out. I have 5 of those. 5 times 4 is 20. I still have 3 left over. So this is times, whoops, not t, times I to the 3rd. So maybe, let me do one extra step. So I want to have powers of 4. So that's 4, 8, 12, 16, 20, 24, etc. So this one I can really write as I to the 20th times I to the 3rd, that's 23. And this I to the 20th I can write as I to the 4th, that's what I want, to the 5th power, times I to the 3rd. So now, I to the 4th is 1, 1 to the 5th power is just 1. So this thing is like I to the 3rd, which we know to be what? Simplified is simply just negative I. So I to the 23rd is really saying the same thing as negative I. So that's it. That's the end of video 1, an introduction to our complex number, the introduction to the imaginary unit, algebra of complex numbers, and lastly our powers of I. So come on back and we'll look at video 2 for this section.